Alright, welcome to section 8.5, U substitution. Woo! This is one of my favorite sections because it is super versatile. We have actually talked about this once already. It was way back when in chapter 5, I believe, with factoring. It's kind of something that people use a lot in calculus. It's actually a really big idea in calculus. It's this idea that you don't like what's currently there, so ditch it. This is a method that works for you. It's not something that you work for. It is a method that works for you. So let's talk about, basically what we're given is some quadratic-y looking type things. Now this works with anything, not just quadratics, but we've been dealing with quadratics for so long that it's definitely easiest now to kind of see how this works on a quadratic because we know what a quadratic form is supposed to look like. But this works on anything. It works on anything you want. So let's look at something that's not necessarily quadratic, but sort of looks quadratic, right? So how does this look quadratic? Well, it's got that same higher power, middle term that's lower, and then a constant on the end, and it equals 0, right? So this looketh quadratic, but it's not exactly quadratic. It's not squared. It is almost there, but not really. So I really want to solve this. I need to solve this for x, but I don't know how to deal with fourth powers. Fourth powers are too high. So I'm going to make what we call a U substitution. Now, a lot of people use U, but frankly, my U's look like weird A's. So I'm going to use a different letter, totally up to you. I'm going to use R. I'm going to change the part of this that I don't like into R, and then I'm going to change this into a quadratic. So how do I change this? Well, if I look here, to the fourth power is the same thing as squared. And if I rewrite it like that, it's pretty clear what's the ugly, weird part here. X squared. If I were to take out x squared and just make it an R, then I'd be good, right? I could solve this really fast. So I'm going to do that. I'm going to make x squared equal to R. Now that I could solve. That I know how to solve. That we've been solving like for months now. So I'm going to quickly factor that because I can. Go over here. R minus 4 and R minus 9. And so R is equal to 4, or R is equal to 9. Cool. Now the bummer part is they didn't ask about they didn't ask about R. They asked about X, right? I need to know what X is. So what am I supposed to do now? Now I do the plug back in step. So I took it out, I took something out, and I replaced it with R. Now I'm going to put that same thing back in, because once I define this is always true. It's always true. So x squared now equals 4, and x squared now equals 9. And I have two little mini equations that I can finish real fast. X squared equals 4, x equals plus or minus 2, x squared equals 9, x equals plus or minus 3. And that's how I get my fourth degree having 4 different answers. Positive 2, negative 2, positive 3, negative 3. So that's U substitution in a nutshell. I could have made that problem 10 times harder by going a different route. Instead, I know how to factor. I know those things pretty well. I've practiced those for a while now. And so I rearranged it by making a substitution of my own choosing. And how to choose you get good at. You just got to practice. You got to kind of mess around with it. And that made my life easier. And so I want to make your life easier, and you can use substitution. Okay, let's try another one. This one, we kind of need to rearrange a few things. It's not quite in order yet. 4x to the 6th minus 5x cubed plus 1. And now we can see it's almost kind of a quadratic, right? Kind of the same logic. Is it almost a quadratic, though? I have to double check something. Well, yeah, it is. If I am able to have this sort of relationship where I have something squared, something single, then a constant, even if that something is x cubed, then I have a quadratic, right? I wouldn't be able to do this if that was a 5, because I couldn't get a squared out of it, right? So I need to figure out what I can get a squared out of. I'm gonna go with b is equal to x cubed, because x cubed is now the thing that's kind of ugly that I want to ditch, because then it's much easier to solve. And then just, if you're still kind of like hesitant about this, just look at these two lines and kind of see what's happening right here. Look at this part and this part. Do you see how that was the ugly that I needed to change into something I could work with? All I had to do was define B. All I had to do was tell the audience B equals this ugly thing, so now I'm going to deal with this as B, not as this ugly thing. Okay, and again, it works for a lot of stuff, not just that, but... Okay, so now I can solve this. Again, I can factor it. If you didn't want to factor, you could use quadratic formula. It's going to take you 8 extra steps, but I'm going to try and factor it. 4 and 1. I could use 2 and 2, but the only way to get 1 would be 1 and 1. To get -5, -4, -1. Cool, solve that. So now I have 4b minus 1 equals 0, or b equals 1 over 4, or b minus 1 equals 0, b equals 1. I'm trying not to take a lot of space. I've mentioned this before in a couple of videos. I don't like to do a lot of the add 1, then divide by 4, because then that takes up a lot of room. But if you have any troubles with that, just come see me. That's all I did there in the first one, was add 1 and then divide by 4. The second one, I just added 1. Okay, but these are not the answers that they wanted, they're the answers that I wanted, right? So I do have to do that last step. I have to plug back in, or I can't finish the problem. I can't actually answer it. So luckily, in Chapter 7, we have now talked about using cubes, or getting rid of cubes, by cubing both sides. Don't need a plus or minus, because the cubes only have one answer there. Cubed root of 1/4 is not going to be super pretty, so I'll just leave it as the cubed root of 1/4. But 1 is pretty easy, so I'll actually take that down to 1. Not bad, not bad. Again, could have been 10 times harder had I tried to solve that with an x cubed. Okay. I recommend you try the next one out on your own. Ooh, okay. And kind of see how this is going. Actually, try the next 1, 2, 3, 4 out on your own. I'm going to breeze through them pretty fast. Okay, here we go. So I'm going to move this over. Okay, first I'm going to write it so that it actually looks like English, or at least math class. Minus 6x squared plus 3 equals 0. I'm going to make y equal to x squared. So y squared minus 6y plus 3 equals 0. This one I cannot factor because the only factors of 3 are 1 and 3, and they do not add to 6, -6. So I'm going to go over here and use quadratic formula. Y is equal to 6 plus or minus 36 minus 4ac all over 2a. 6 plus or minus 36 minus 12 would be 24. Okay, I can simplify that 24. I can't simplify it all the way to a whole number, but at least I could take out, let's see, 6, 4, 2 root 6. And because of that, I can now divide these, and I get 3 plus or minus root 6. Not the prettiest. That's okay. Unfortunately, though, I was still asked about x, not y. And I'm bleeding into the next problem, so we'll go back a little bit. So I have to plug that in now. X squared is equal to 3 plus or minus root 6. How do I solve this? I'm not going to let that right-hand side worry me. I'm just going to square root both sides. Go to plus or minus the square root 3 plus or minus root 6. And that's how you get your 4 answers. Plus root 3 plus root 6, plus root 3 minus root 6, minus root 3 plus root 6, and minus root 3 minus root 6. Those are 4 different decimals, but I'm not taking the time to write them all. I'm just going to write them like that. It's ugly. Kind of knew it was going to be ugly because the section is called ugly stuff. But that's okay. I mean, notice I could still just do quadratic formula, and I could square root both sides. And even though the answer's not super pretty, it is accurate. Cool. Let's try another one. In this one, I again am going to let y be x squared. And so we get y squared plus 25y plus 144 is equal to 0. Noticing a lot of squareds. 4 So 12 and 1 be 24. So that would not be a perfect square, unfortunately. So let's use quadratic formula. Oh, wait. 144 is 16 times 9. Right? Yeah. 144 divided by 9 is 16, and 16 plus 9 is 25. Yeah, okay, so this factors into y plus 9 and y plus 16. Or you could use quadratic formula. I don't really care at this point. So y equals negative 9 or negative 16. Okay, but again, that's not really my answer. My answer is going to be an x. So x equals negative 9, or x squared equals negative 16. Square root both sides, x equals negative the square root of negative 9, or the square root of negative 4, and that's plus or minus. And so we get x is equal to plus or minus 3i and plus or minus 2i. Some complex answers out of these bad boys. Again, this section really should be titled Ugly Crap. Like, ugly stuff. That's really what it should be called. But notice it was much easier to solve that when I could use U substitution. I could solve that formula pretty fast. Or solve that factoring pretty fast. Okay, one more. Or two more. Again, I'm going to let y equals x squared. Y squared minus 37 y plus 36 equals 0. This 2 shall factor y minus 36 and y minus 1. So y equals 36 and y equals 1. Again, I'm going pretty fast through these because I wanted you to try these ones out on your own. But if you have questions on them, luckily it's video, you can slow it down. Or you could come see me in person or shoot me a message or a Canvas email. Okay, so again, that's y. So x squared now equals 36, or x squared equals 1. X equals plus or minus 6, or x equals plus or minus 1. Wow, that one was much prettier, huh? Much, much prettier. Okay, and then the last one of these is going to be this guy here. Okay, again, y equals x squared. No, it's not always going to be y equals x squared, as we've seen, right? But this is good practice with ones that are kind of ugly to begin with. So 9y squared minus 25y plus 16 equals 0. That's a 3, and that's a 4 squared. 3 times 4 is 12 times 2. So this is not a perfect square. But, again, 9 times 16 is 144, and 25 is 9 plus 16. So I'm thinking it factors. I'm thinking it factors into 9y minus 16 and y minus 1. Because that would give me negative 9 and negative 16, which is negative 25. But it gives me positive 16 on the end and 9 on the front. Okay. So then we get that y equals 16 over 9 and y equals 1. But y is x squared, so x squared equals 16 over 9 and x squared equals 1. Square root both sides, you get x is equal to the square root of 16 over 9. Or x is equal to the plus or minus square root of 1. This one's pretty easy to see. It's just going to be plus or minus 1. But this one, we have 16 and 9, so 4 over 3, so plus or minus 4/3 would be our answers. Okay, now the second parts of those, like how do I square root both sides, or how do I factor this thing, or how do I use quadratic formula, all of that is previous chapter, which means that you should know it by now. But if that's not the case, if you never finished learning that, then please come see me as fast as humanly possible, because there is the proof that you will need it. You need to be able to do this. The new stuff, though, is this very beginning thing here. Not super horrible. Y is equal to x squared. Like, we really just substituted it out, okay? So that's kind of the key point here. We can do it with stuff other than higher powers, though that is the place you will find it most often. Let's look at this one. Give yourself like 5 full seconds to look at that and see how I can apply U substitution here. Okay, what could we do? This is the ugly part, right? Now, option number 1, we could make our lives incredibly difficult. We could square that thing out, We could multiply the 7 in, we could multiply the 2 in, we could get it down to a polynomial, and then we could solve it. Then we could factor it, then we could figure out what x was. But instead, why don't we just rearrange this and take the ugly part out? I'm going to go with, I'm so sick of y, we're going to do p. P is equal to 4x minus 40. 4x minus 3. That thing that is almost quadratic, but it's kind of in the way. So we're going to get it out. 2p squared plus 7p plus 5 equals 0. Seriously, think way back to chapter 4. It's just a substitution. I am substituting out p for this thing. So powerful, and yet so overlooked. Okay, yeah, I can factor that real fast. 2 and p are the only way to get p, 2p squared. 5 and 1 are the only way to get 5. And then 2 plus 5 would be 7. Cool beans. Okay, so 2p plus 5 is equal to 0. Or p plus 1 is equal to 0. P is equal to negative 5 halves. P is equal to negative 1. But really, it's not p, so now we gotta plug this back in. I have a better idea. So notice how this ended up in a fraction, right? This wasn't the probably best time to sub back in. I think the best time to sub back in was here before I solved it. And that's entirely up to me. It's entirely up to me where I want to sub this back in. I could do it now, but then I would have to deal with this fraction thing. Instead, I think what I'm going to do is I'm going to not solve it yet, but sub it back in instead. So 4x minus 3 plus 5 equals 0, and 4x minus 3 plus 1 equals 0. Okay, now these I know how to solve. Now I know how to solve the other one too, don't get me wrong. Like, it's not that hard to multiply and make halves and stuff, but you know, we don't like to deal with fractions, we kind of avoid them. So I can do it this way. I get 8x equal, minus 1 equals 0, or x equals 1/8, which I could have found the other way. Or I get 4x minus 2, or x equals 1/2. And yes, from past experience, I know I get the exact same thing. Cool. So you can sub in wherever you want. Totally up to you. Alright, moving right along. Let's do another one. What should I sub out of this one? Try it on your own. Okay, hope you tried it on your own. I'm going to make it m. Oops. It's always a good idea to write down what exactly you're substituting, because then you don't have a problem going back and doing it later. If you just kind of take it out, you're more likely to just forget that it exists altogether. Okay, factor that. M plus 5, m minus 4. We get m is equal to negative 5, positive 4. I don't think it really matters here whether you plug it in before you solve or plug it in after you solve, because I just could probably solve these ones pretty fast. And then k minus 4 equals 4, negative 4. Nope, positive 4. And then solve both of these. You get k equals negative 9 or k equals 8. No, not negative 9. Sorry. Dumb moment there. Try negative 1. There we go. Or k equals 8. Ta-da! Alright, the last thing we can do is kind of the same idea. Instead of higher exponents, we could also deal with fractional exponents, so kind of lower exponents. We need them to be squared. So if I rewrite this one kind of the same way, we can see what we should sub out. The x would probably be, I'm sorry, let's do s. No, s is alright. T will be x to the 1/3. Then I don't have to deal with this fraction yet. So I get t, 2t squared minus 11t plus 12 equals 0. So again, kind of stare at that for a moment. Kind of see the coordination, right? You take out the x to the third, you put in a t. Then you can solve this. Maybe it factors? Well, it's got to be 2t and 1t. 12, 6 would be 2, and 6 would be 12, and then 2 would be 10, so no. 4 would be 8 and 3. Yeah, 4 would be 8 and 3. So I could do 8 and 3. Both of them negative would give me 11, and that's how I get my factored form. Not going to sub back in yet. We get t equals 3/2, or t equals 4. Now I'm going to sub back in. Don't let this panic you. Oops. If you recall, 2 to the 1/3 means cube root, right? And so the opposite would be cubing. Another way to look at it, this kind of 3 times 1/3 would make x equal 1. So I cube both sides. Sorry, I'm doing them both at the same time for some reason. And I get x is equal to, nope, just kidding, 27 over 8, or x is equal to 64. And we're good. Again, that's from previous chapters, so if you have any questions on that, you can come see me. Try this last one out on your own, though. See if you can make it work, and then we'll do it together. All right, so here we go. I'm gonna make it x this time. Booyah! I'm gonna make it x equals t to the 2/3. Some people see this and they start to develop this, just make it the middle one, right? And that's fine, like, that's okay. 9 times out of 10, you're probably right, but you have to be careful that it still matches this part. You have to be careful that you still get 9x squared out of that. In this case, we do, okay? Because if that was a 5/3, that's not the same. You can't just make it work, right? You have to make sure it still follows the rules of math. So just be careful about that. 25x plus 16, pardon me, equals 0. Alrighty, so now I already factored this one earlier. So I know it'd be 9x. Okay, hold on. It'd be 9x minus 16 and x minus 1 equals 0. So x equals 16 over 9 and x equals 1. Cool. Okay, but we're not really concerned with x. So t to the 2/3 equals 16 over 9. T to the 2/3 equals, so lopsided 1. Start with this one now. To the 2/3 means I want to raise this to the 3/2. Whoops. Sorry, I wanted to put it here. So that those will all cancel to 1. Raise that to the 3/2. So we get t is equal to 16 over 9 to the 3/2, which is the same thing. Oh, I've run out of page. As, we'll go this way. The cubed root, nope, just kidding. The square root of 16 over 9 cubed. 16 over 9 is 4/3, and cubed would be 64 over 27. So I broke that down. Let's do the same thing for 1 now. T is equal to 1 to the 3/2, which is equal to the square root of 1 cubed, which is equal to 1 cubed, which is equal to 1. And we're done. Okay, once again, all that past stuff, come see me in person if you need help with it. Or if you need help with your substitution, just shoot me an email, send me a message on Canvas, come see me. Otherwise, happy homework.